Arizona has always been known for its sunshine. Can it now also become known for its solar technology and leadership?
We're right now on track to meet the Arizona Renewable Energy Standard of generating 15% of our total resource needs by 2025.
Tonight on Arizona Week, turning solar energy into economic viability.
Production of Arizona Week is made possible in parts by a grant from the Stonewall Foundation and by the members of Arizona Public Media. Thank you for your continued support.
Once again, your moderator, Michael Chiha.
We're just outside of Gila Bend amid the state's largest array of solar collectors, owned and operated by Arizona Public Service, the state's largest utility. This is no longer an experiment for APS. This is economic reality. What is APS's mission with solar?
Well, our mission is to balance our resource portfolio in serving our customers with reliable energy for the long term by incorporating renewable energy as a part of the mix. We've got nuclear, coal, natural gas, and now we're increasing our renewable technology to make sure that we continue to balance that portfolio over the long term while providing clean, reliable energy to our customers.
We're at the Paloma Solar Station outside of Gila Bend. Tell us a little bit about it. What is this and what's it generating?
We're very proud of this facility. It's a 17 megawatt solar photovoltaic plant. It came online last year in 2011. This facility is an APS-owned and operated solar plant. We developed it as a part of our AZ Sun program, which is a program where we're investing in developing up to 200 megawatts of solar photovoltaic plants between now and 2015. Again, this plant was brought online in 2011. It started serving over 4,000 homes every year, produces about 40,000 megawatt hours, and it's developed with thin film technology by First Solar. So it's truly an Arizona plant, APS-owned, Tempe-based First Solar developed, and it was really a remarkable achievement from groundbreaking to generating electricity in less than 4 months.
Tell us how these panels convert sunlight into electricity.
Oh, absolutely. It's really quite a simple process. So this is thin film technology, which is really thin layers of glass that sandwich a silicone product. And when the silicon product receives the direct rays of the sun, it heats up the silicon and excites electrons inside. And those excited electrons create electricity. It's in direct current form, and so that direct current electricity makes its way to an inverter on the project site, which converts it from direct current to alternating current, AC. That's the conventional form that electricity is transmitted on our transmission grid. And so from the project site, it enters the transmission grid, all 17 megawatts, and begins servicing our customers.
And the 200 megawatts that you said will eventually be generated, how much will that serve?
That'll serve over 50,000 Arizona homes.
And the cost of that?
The program was initially authorized to be developed for under $5 a watt. Because solar costs have been declining, we certainly expect to complete the program less than that cost, but that was the initial authorization.
And how does that compare with your conventional costs for generating electricity?
Well, it's tough to compare because, of course, conventional generation is both an installation cost and an ongoing fuel source, but it generates electricity for our customers around the clock, so even when the sun sets. Whereas solar plants, it's really, in large part, the initial installation cost, which is substantially higher still than conventional generation, but then over time you save on not having to use fuel to generate electricity. So when we look at it over the long term, solar is still more expensive than conventional generation, but we still believe that that balanced portfolio of technologies is the right solution going forward.
And for APS now, the biggest utility, electric utility in the state, break down the percentages, if you would, or the proportions of electrical generation from various sources.
You know, when we reach 2015, where our target is to have about 3.4 million megawatt hours generated by renewables, we expect that the breakdown will be roughly about a third nuclear, a third natural gas, a third from our existing coal fleet, and then we'll have about 10% of that total portfolio be from our renewable resources.
Are there cost drivers for solar in addition to the technology?
You know, on an ongoing basis, one of the advantages we've seen from plants like Paloma is that there's no ongoing regular maintenance requirement. So there's no water usage. This is an unmanned facility. It's not staffed. So we're proud of the fact that beyond the initial installation, the plant is really sitting here reliably producing clean energy for our customers without that ongoing maintenance need other than normal preventative maintenance.
There are government goals in regard to solar or renewables. Where is APS in relation to those?
So we're right now on track to meet the Arizona Renewable Energy Standard of generating 15% of our total resource needs by 2025 to be from renewable resources. In addition to that, APS is committed to accelerate that goal by generating about 3.4 million megawatt hours of renewables to service our customers by 2015. We're on track to meet that. So about 12% of our total energy portfolio in 2015 will be serviced by renewable resources.
Obviously, it's about economics, but would you see APS going beyond the government requirements if it were economically feasible?
Right now, our plan is to stay perfectly on track with that requirement. It's the right thing to do in terms of balancing the technology and the cost, and then we'll work with regulators to see what the plan is beyond that point.
Can you look out a decade or so and say what you think the mix will be at that point?
Yeah, it's an excellent question, and for us, it's a constant evaluation of where fuel prices go, where there's environmental policy for different technologies, and where the costs of new technology, such as solar, ends up. So it's a constant evaluation to make sure that we balance the right mix of reliable technology with affordable, clean resources to ultimately provide the best solution for our customers over the long term.
And even within solar, there are different technologies. Is that not correct? This array, for example, is one technology, yet APS has a couple of others in the works in this very vicinity.
That's absolutely correct. Varying technologies, our approach is to always stick with sort of the proven technologies. We're not in this at this point to have test labs or technologies. We look for the proven technologies that are going to be here servicing our customers for the long term. But in this region, for example, we have the Paloma plant, which is a thin film solar photovoltaic. Right next door, we have the Cotton Center plant, which is a polycrystalline single-axis tracking technology where the panels actually move from east to west following the sun every day. And then down the road, there's the Abengoa solar facility, which is currently under construction. That is going to be a plant that APS will purchase the power from to serve our customers. That's a solar thermal technology, which essentially takes the energy from the sun, heats up a fluid that then creates steam to turn a conventional steam turbine. The unique attribute of that plant is it also has storage capabilities, so once the sun sets every day, the plant will still be capable of producing energy for about 6 hours past that point, a unique feature that will certainly help us maintain good reliability.
Now, you talked about government goals that are set in place for you to meet as far as renewables go. What kind of government support is there for utilities to be able to meet those goals?
You know, I think there's tremendous government support. Certainly these projects are still heavily dependent on investment tax credits for solar and renewable technologies. So each of these plants is benefiting from that. APS's approach, of course, has been able to utilize those credits, pass them on to our customers to help maintain an overall cost savings for these plants. But in general, obviously, we've all benefited from that support. In the local community here of Gila Bend, the town of Gila Bend has actually set up a fast-track permitting program to help expedite the development process for plants like Paloma. A typical permitting process for this plant would take anywhere from 6 months to a year, and their program, it's called the Solar Field Overlay Zone, has taken that 6 to 12-month process, reduced it to about a month. So it's enabled developers and utilities like APS to really take advantage of developing these plants efficiently and in a more cost-effective manner.
The technologies and the tax incentives that APS is using to build more solar electricity generation are also available to the average resident and small business. In Tucson, fast-growing numbers of smaller operations are in the works. I learned about them in an earlier interview from Kevin Cook of Technicians for Sustainability. Kevin Cook, welcome to the program.
Thank you.
Tell us, what is Technicians for Sustainability? What do you do?
We are a design and build construction company, really, that we're focused on installing solar hot water and solar electric systems for residential and small commercial customers in the Tucson area.
And when did your business start, and how has it grown?
Well, I personally got involved in solar in 1998, but took a few years to evolve into Technicians for Sustainability. It started in 2003. There were two of us that made up the company for really through 2006. And from 2006 through today, we've had quite a steady and fairly substantial growth from those two people to about 45 people today.
Now, everyone's impression would be that solar is a growth industry. Is that true?
It has certainly been true for us. The last 5 years, we've seen a very steady growth of both personnel as well as the number of systems that we're installing in Tucson every year. So we've gone from installing dozens of systems a year back in 2005 to installing 150 to 200 systems a year today, and the city in general is also seeing a similar increase. We're now at over 1,000 installs per year in TEP service territory.
You were telling me before we came into the studio that there are many things that sustain the growth, including some tax incentives. Talk a little bit about what is driving the growth in solar.
Mm-hmm. The very first thing that drives the growth is citizen interest. So people in Tucson are interested in solar. They want solar on their homes. They're asking for it. So that's the foundation. In terms of making it financially accessible to people, the industry is supported by, we've seen tremendous decrease in the cost of the equipment, as well as an efficiency of installers like myself, bringing our cost to install a system down. And then on top of that, still helping to supplement the cost, we have federal tax credits available. There's a 30% tax credit. There's a state tax credit of about $1,000 available. And the utilities are still supporting solar with incentives that are funded through a mandate by the Corporation Commission.
But some of those incentives are changing as we speak. Is that not correct?
That is true. The incentives have been, particularly the utility incentives, have been tracking the market. So as installations become more affordable, sometimes so affordable that you're looking at 2 or 3 year paybacks, the incentives will drop, because naturally when people hear that, you see massive adoption. The incentive monies run out, and the Corporation Commission approves a lower incentive level. So 3-4 years ago, we were seeing incentives at $3 a watt. They went down to $2, down to $1. We're now down at 50 cents a watt that the utilities will pay for the incentives. So they do change in line with the market bringing its costs down.
That 50 cents a watt that you refer to, that's what a utility would pay a resident for the electricity being generated in the solar system that's surplus?
That is what Tucson Electric Power will pay a customer within their service territory in exchange for the renewable energy credits associated with their installation. So it's not so much that they pay for the energy that's produced as that they're buying the environmental attributes of that energy produced over the next 20 years. And
so does the system maintain its economic viability in a free market, or are these incentives still going to be needed for a while?
Well, that's a good question. There are markets within the United States where incentives are not required. We are certainly in the case in Tucson Electric Power, in the Tucson area, that some form of those incentives are still required. And I think we probably will be for some time. And a lot of it depends on the dynamic between electric prices. As electric prices go up, the need for those incentives will come down. And as the cost to install a system comes down, the need for those incentives will also drop. But at this point, we are getting very close to not needing the utility incentive, although I think it's still necessary. We are still fairly dependent on the 30% tax credit from the federal government.
And is there an expiration on that, or will that go on?
That is currently set through 2016. Whether that gets renewed or is let to sunset is yet to be seen.
And the average resident who is interested in solar installation can look at the incentives and say, this is for me now because I can afford it using these tax credits and other incentives. But is there some kind of a political pressure that should be brought to bear to continue aiding the market, if you will?
Well, we stand at a really interesting place right now in the solar industry where federal policy, state policy, as well as Corporation Commission level policy has all provided significant support that's really been behind this tremendous growth we've seen in the past 5-6 years. we are at a point now where that support is in question. And I think citizens who are interested in seeing the momentum that's been built up in terms of the jobs that have been built and the amount of renewable energy that has been deployed in southern Arizona and can continue to be deployed on people's homes and businesses, I think people, if they're interested in that, really need to pay attention to the Corporation Commission election coming up this fall, and more importantly, whoever's elected, they need to hear from Tucsonans that we want to see solar continue to be viable and continue to be supported until it can stand on its own.
Kevin Cook of Technicians for Sustainability, thanks so much for being with me.
You're welcome. Thank you for having me.
While solar energy generation is a reality, there's still plenty of room for research and experimentation. The University of Arizona has a unique project underway via its Optical Sciences Department. Arizona Week producer-intern Paul Ingram brings us the story.
On the University of Arizona campus, Dr. Roger Angel and his team, in a partnership with Renew Energy, have designed a system that could make solar energy competitive with oil and gas. Blake Kokenauer, a graduate student with the Optical Sciences Department, worked on the project.
This is our solar tracking device. So this is our system that we've been designing and working on over the last 2 years to create solar power through concentrated photovoltaics. What's different about it compared to most solar energy systems is that instead of using large PV panels, we use a small amount of PV material at the focus of a very large mirror. So behind us, there's this 3 by 3 meter mirror that takes in about 10 kilowatts of power, and if it was all covered with PV panels, then it would generate maybe about 1 kilowatt of power, meaning about 10% efficient, 1 kilowatt of power out for 10 kilowatts of sunlight in. But our system rather does 3 kilowatts of power out for 10 kilowatts of power in. So it's nearly 30% efficient. The other big special thing about that is we need to track the sun all day. That's a lot different than most PV panels, which you can just take and stick on your roof and generate power throughout the day. The advantages are that we can point at the sun from the time it comes up over the horizon to the time it goes down at the end of the day. This whole system by itself, if it was all populated with our little solar tracking concentrators all through them, we only have one here in the background that's working currently. If it had 8 fully populated in all of the structures on the tracker, it would generate between 20 and 25 kilowatts of power. And that's enough to power maybe 2 to 3 homes. This is something that you would put in a utility scale infrastructure way out in the desert somewhere. So that you would have a lot of these trackers side by side by side, separated by maybe 50 meters or less, and they would have many of them lined up across the horizon. A year ago when we were doing this, we were using cells that weren't really made exactly to what our specifications needed to be in our weird curved surfaces. So we were using real thick copper bars to connect pieces and run them in a series chain. Since then, we looked at what the problems were in making that, because it took us about a month to put the whole thing together. And we realized, well, if we can get the manufacturers of the cells to put these different leads on it, an in and out lead, it's really just like a battery, a positive and negative voltage part. If we can make these leads that'll come up, we can connect them side by side in a nice series chain that goes back and forth. And so that's what we've done here. When we can put these together this time, it only took us about a day or a day and a half to put them all into the whole system with little screws and wire them all to each other. So that's a whole lot quicker way to do it. It's still by hand, but we've learned what's a quicker way to do it than bending hard pieces of copper and figuring out how everything should run. In the future, what we would try to make the whole system more manufacturable by making it either a smaller system or have less curvature to it. Maybe instead of copper, it might be made out of plastic. It could be molded and replicated in large quantities. This is a 1/4-inch thick piece of steel. Whenever we put all the sunlight into one focus, we can burn a hole in it with our mirror in about 5 seconds. And so it's a lot of light going into the whole system. It is safe, but it's still putting a lot of light into one little place. So what we do in our system is after it comes off that mirror, it comes down to a focus. And at the focus, instead of having a piece of steel where it melts and burns stuff, we put a fused silica, it's a special kind of glass, ball lens. And this glass is special in its properties in that it's highly transmissive to all the wavelengths that the solar spectrum is coming in through our atmosphere. So after the light travels through the ball lens, we want to distribute the light from the mirror onto an array of these CPV cells. And to do that, we have to separate the light up equally that's coming off of it. So the lens is placed kind of in arrangement right about here above an array of funnels. So after our light goes through our funnels, which you see here are attached really closely at the very front, it distributes them down to a smaller surface on the back. If we didn't have a cooling system, the cells would heat up to a couple hundred degrees centigrade and they would melt, maybe in about 5 to 10 seconds. We've done it for a couple seconds with everything without our pump and our fans running, and just having water behind there has kept them from melting right away. So that's great. But a lot of people run their cooling systems of their cells in the same way, but without liquid. They use a big passive heat sink, so that adds to a lot of the mass of the system. Since ours is a nice tight array, all the energy and power and the water, everything needs to be in a nice small system right at the focus. This puts it all into one spot so we can cool all the cells together. What you see is a bunch of little tiny pins that accept the water of our water cooling system. It's a closed loop liquid cooling system, and it's very similar to the cooling system you might have, a water cooling system for, say, a CPU in your PC. So we keep the water from boiling and we keep the cells from melting, and we do that by pushing the water through all these fins very quickly, high velocity, and circling it through a bunch of radiators that comes back out, and blowing nice, real efficient fans through those radiators to blow air through to cool the water. So the water will only cool by maybe 10 or 20 degrees as it goes through our closed loop cooling system, but that's enough to take all the heat out of the cells in real time, constantly. And another big reason you want to keep your cells cool is actually for their efficiency. And so our cells being actively cooled with a water cooling system will be a lot more efficient for their size than another system that was using passive cooling. If we had it our way and we had all the money in the world, we would have it out in the field maybe in the next two to 3 years in a big commercial viable kind of plant, maybe 1 megawatt size. But it really depends on the money. So nothing really stopping us at this point. All the designs are as about efficient as they can be, and we've done a lot of market analysis and understanding of the cost of manufacturing, and now we're just out there raising the money to make it happen.
Thanks to Paul Ingram for that story. To close out our report on the growth of solar electricity generation in Arizona, David Hutchins joins us. Mr. Hutchins is president of UNS Energy Corporation, the parent company of Tucson Electric Power. Welcome.
Thank you, Michael.
Tucson Electric just won an award as Utility of the Year from the Solar Electric Power Association. What was that award for?
That award was it really recognized us as a leader in the solar industry. And what makes that award especially nice is that it's basically an award from your peers. It's a group of utilities, investor-owned municipalities, et cetera, as well as solar companies that belong to the Solar Electric Power Association. And why it means so much to us is it shows that we really are making the right efforts, that we're doing the right things from a solar community perspective, looking at the right kind of projects, the right kind of programs, and getting involved in research and development where we can, which we do a lot of here in southern Arizona.
Research and development, but you also are generating electricity for residential and business use in your service area. How much are you generating from solar now?
Yes, right now we're generating between probably about 70 and 80 megawatts in our system here in southern Arizona, but that's really just the tip of the iceberg. Over the next year and a half, we will grow that to over 200 megawatts, which sounds, what's a megawatt? What does that really mean? How does that translate to something that's meaningful? That 200 megawatts will provide enough electricity for about 50,000 of our customers, which is very substantial.
Does that put you on track to meet the state's requirement for 15% renewables generation by, I think it's 2025?
Yes, that's right, 15% by 2025, and we are on track. Actually, we're ahead of the game. We had entered into several purchase power agreements and agreements to build some of our own solar facilities, and the drop in solar prices has enabled those to all go through. So we're actually a little bit ahead of the game right now, which is nice.
Do you expect to see prices continue to drop? Will we eventually have a fully free market in solar?
I don't know if it will be fully free, but we definitely see the cost drop. The thing that sort of
competes with that a little bit is, as much as you talk about solar, you probably hear about natural gas and shale gas, et cetera, and that price is pretty low too. So that's what competes sort of head to head with solar. But we expect, we fully expect solar to become cheaper and cheaper as we go out into the future, even when you take into account, maybe the loss of some of these subsidies and tax credits and things like that. As well as the cost of integrating it into our system. That's a technology, specifically photovoltaic energy, that will be on a very good downward price slope, I think, for a long time to come. Whereas natural gas, we know what it is today, and that's about all we can say.
What is the number of homes and small businesses in the Tucson area generating electricity from solar and somewhat off the grid, perhaps?
Yeah, they're not quite off the grid. What they do is they put panels on their homes or businesses that will offset some of their energy use, and when they're not using it, will feed back onto the grid, and then it basically is there for their use through a net metering rule from the state, which provides them this ability to net that production. But we have about 6,000 customers who currently have solar on their home or business, and we add about, right now, 1,000 a year, which is a very big clip. That's 5 to 6 times higher than it was just 3 years ago, and that goes to show how drastic that price drop has been over the past 2 to 3 years.
We have about a minute remaining, and in that time, would you tell us what kind of investment UNS and TEP are making in research, including research perhaps here at the University of Arizona?
Oh, we do a lot with the University of Arizona. We do a lot of R&D with AZ-RISE, which is Arizona Research Institute for Solar Energy, and we work hand in glove with those folks on looking at new technologies. We actually work and we've got a spot set aside for Dr. Angel's project out at the U of A Science and Tech Park, which is another partnership with a different part of the University of Arizona, where it's basically, I would call it the premier multi-technology solar facility in the nation. It has many large facilities out there that we can test drive, basically, and see which works best for us.
David Hutchins, president of UNS Energy Corporation, the parent company of Tucson Electric Power. Thanks for being here to speak with me.
Oh, you're welcome, Michael. Thank you.
That's our program for Friday, July 27th, 2012. For more on solar energy in Arizona, go to our website, azweek.com. Next Friday, a conversation with Governor Jan Brewer. For Arizona Week, I'm Michael Chihak.
Production of Arizona Week is made possible in parts by a grant from the Stonewall Foundation and by the members of Arizona Public Media. Thank you for your continued support.